Okay guys, the task today is to solve equations with complex roots. Like I'll remind you that if you've got a quadratic equation, the degree is 2, you must expect to get 2 roots. In the case of where you've got a degree 3, you must expect to get 3 roots. If there are complex roots involved there, the complex roots are going to come in pairs. Now it's a complex number and there is conjugate. So what I'm going to do here, I'm going to ask you to do these examples on your own. And what I'm going to do, I'm just going to explain one long example of degree 5. And I would like you to master how we go about this thing. Then you can also be able to do this one. Like I said before, I'm going to ask you to hand in one of these problems completely solved for me to look at exactly what you've done. So in this case, to learn what we're going to do, we're going to look at this problem of degree 5, but I'm going to change this question, not exactly as it is now. Let me write, we've altered the equation to 2z power 5 plus 4z to power 4 minus 2z squared minus 4z. Now, as you can see, the polynomial is of degree 5. So, whilst starting working on it, you must have it in back of mind that this is going to give us 5 roots. Yeah. Then, 5 roots actually is equivalent to saying 5 factors. Yeah. So now, let's start by rewriting this polynomial here. I'll write it this way as P5 to emphasize that is a polynomial of degree 5, and you will understand later why am I using this 5 as we move. I'll show you why I'm using that 5 as P5. Then 2z power 5 plus 4z power 4 minus 2z power 2. Let me include one term here which is not obvious in the expression. Then they say plus 0z power 3 minus 2z power 2 minus 4z. Right. So my writing of 0z to power cube there is to make you understand also that if you see a power not appearing on the polynomial like that, it just means that the coefficient is equal to 0. But it's going to be useful here because we're not going to do long division. We're going to need that somehow for our organization. Now, let's start by, let's start our initial step, call it 0, step 0 there. Now, we need at this point to evoke our factor theorem. Our factor theorem says if we've got a polynomial like this, like say we've got P5 here, and we find out that if we evaluate P5 at a number A, we get 0. Then we're guaranteed of the fact that z minus a, this binomial, is going to be a factor of the polynomial given. Now, it is clear then that if you substitute z by 0 throughout this polynomial, we're going to get p of a equal to 0. Now, if we set a equals to 0 and substitute here, we're going to get 0, which means then z minus 0, this binomial, is a factor of this polynomial, but you can simply write this as z in the simplest way. Altogether. Now we come to a point whereby we know that this is a factor. Obviously, this is a factor of power 1. To produce a polynomial of degree 5, we must multiply by another polynomial, isn't it? So how do we get that polynomial? We know that 3 is a factor of 6, isn't it? How do you get the other factor? To multiply 3 to get 6. We divide, isn't it? So now what you can do now, when you divide, you get the other factor. In this case, the other factor will be P4, a polynomial of degree 4. That's why I'm using these numbers here, so that I can move step by step to different polynomials of different degrees. So now, here is going to be P5 of z divided by z, which you can see is going to give us 2 z power 4. I'm dividing this by z. Then dividing every term, the next term we're going to get 4 z power 3 plus 0 z power 2 minus 2 z power 1 minus 4. All together? Is that all right? Okay. So now I'll call upon another theorem here. I'm not going to give a name of whether the theorem is called factor theorem or what, but it's a theorem on getting zeros of a polynomial like this one. Let's go then to step number 1. Step number 1, we're dealing with the P4. This is our initial step. Then we're going to get step number 1. P4 is equals to 2 z power 4 plus 4 plus 4z plus 4z cubed plus 0 z squared minus 2z minus 4. Now the theorem I'm making reference to is about how to get zeros of this polynomial. Why am I focusing on zeros? Because we know that if we know a zero, we know a factor. We are factorizing it, we want to factorize this completely. So if we know a zero, we got a factor. Now, the theorem says the zeros of this polynomial actually have got this rational form. Let's write here possible zeros. Possible zeros. They are going to have this form. They are going to be of the form d over L. And then you should have a question there. And so the question is, what is d, what is L? Then let's mark d and L there permanent so that you cannot forget that. D is going to be this term here, which is our independent vector. And then the other L is going to be this leading coefficient. My naming of these two parameters is suggesting to you L for leading, D for independent. I can't use I because now I'm using complex numbers here. You might confuse I with a imaginary root. You understand what I'm saying? So independent, D there is emphasized, so I'm using D there. But actually, these zeros, they are of this nature, a rational nature. How do I get them? I actually have got to get factors of D, divide them by factors of L. Those ratios, they're going to give me what? Those, when I divide like that, they're going to give me possible zeros. Now to verify whether this is a zero, what am I going to do? I'm going to do this first thing I did here. I evaluated that point and see whether I get 0. Once I get 0, I can create a factor for the polynomial. Am I making myself clear? Am I making myself clear, guys? Hello? Okay. So now, let's then get the factors of D. The factors of D, let's get the factors of D here. Let me check our usual ink there. D is actually equals to minus 4. Now, if I were to get factors of D, factors of D, I'm now talking about factors here. Let me write factors. In this case, I'm talking about D. It will be plus or minus 1. Because I can take minus 1 times minus 4, I get, so minus 1 times 4, I get 4. So 1 plus or minus 1 is a factor. If I take plus 1, I go to multiply by minus 4. So that's one of the factors. Do you agree? Then the next factor will be plus or minus 2. If I want to get minus 4, if I consider a factor 2, I will take a minus 2 and a plus 2. Then next, it will plus or minus 4. Now, plus or minus 4, obviously, in this case, if I take a minus 4 and a plus 1 here is a factor, if I take a minus 1 and 4 there, it's still the same thing. So those are factors of t. So the next thing is to look at factors of L. And the L in this case is 2. Then I start down say here, say factors. What are factors of 2? I think plus or minus 1. If we took 2 minus 1s, we will produce a minus 1 and a minus 2 will produce 2. If we took a plus 1 and a 2, we will produce 2. So those are factors. The other factors are plus, minus, 2. And the 2 is a prime number. It can only have only 2 possible factors, 1 or 2 itself, isn't it? So that's okay. So now the zeros, let's now say possible zeros. Possible zeros. This is actually going to be a set. It's not only one, it's a set. So it's going to be plus 1 or minus 1 divided by plus 1 or minus 1. So let's check. This plus 1 here, I'm taking it as a factor of 4. And this plus or minus 1 is a factor of 2. Because they said the zeros are in form of a ratio of this nature, isn't it? You understand what I'm saying? Okay. Then the next thing will be taking plus or minus 2 divided by plus or minus 1. And then I'll have plus or minus 4 divided by plus or minus 1. If you check what I'm doing there, I'm holding on one factor in the denominator and dividing all of them, isn't it? Because those are possibilities. I cannot say this one is the one and that one. I will test which one is really 0. Then the next thing is, let's come to the next thing here. Let me just put some separation here and say semicolon there and semicolon there. I think the next thing, let's go to plus 2. What am I saying here? Okay, we can now go plus or minus 2 and taking this one. Then divided by plus or minus 2 from this side, isn't it? Okay. And also, I can take plus or minus 1, this minus 1, divided by plus or minus 2. Now, I think I'll need an eraser here. You've got the list of those zeros there. There's not a problem. So, then we can have the next one as plus or minus 4 divided by plus or minus 2. So 2 has gone through all of them, is it? Is there another possibility left? Just check. But you'll see here that I think there are some things which are repeated. You see that this one will give us plus or minus 1. And this one is going to give us plus or minus 1, isn't it? So what we're doing there, we are just eliminating redundancy, things which are redundant. So from those two, we're going to get plus or minus 1. Whether I use this one or that one, we're going to get plus or minus 1. So I'm making the possibilities look less, and actually they're less. Then we're going to have this one, which is plus or minus 2. But this one is also going to give us plus or minus 2. Do you see that? So then plus or minus 2. Then what else? This one is going to give us plus or minus half. Plus or minus half. What else? Plus or minus 4 from this one, isn't it? Then you got plus or minus 4. That's that. Now, your task will be now to concentrate on these few numbers and try to check which one of the two can deliver you a what? A 0. Now, I think I'm going to do a bit of cheating here because I prepared this thing. I know which one is going to do. So instead of wasting time with other, you can test the other ones. But I think 1 is going to give you a 0. Let's get P41. Let's get P41. What are we getting here? This is 1, is it? It's going to give us 2. This is 1, going to give us plus 4. Are we together? This is 0. We cannot count that. This is 1. It's going to give us minus 2. This is 4. It's going to give us minus 4. Then equals 0. Are we together? So what can we say? You can say now, therefore, Z minus 1 is a factor of P4. But if it's a factor of P4, it's a factor of P5, isn't it? You follow that, isn't it? Yeah. Right. So now we go there. Now what we need to do now, we can now say therefore P3 is going to be P4. Can you complete? P4 divided by Z. By Z minus 1. We're talking about the factor Z minus 1. By Z minus 1. So then, when you come hit this point, you must know your long division. I know this must be irritating some people. Division again, long division. Why? You need it. You need it. So now, let's do the long division. Now we must remember now, the long division is to try to find out P3. I didn't write this completely here. P3 of Z. So let's do the long division. What is our P4? Our P4, I don't like this. Our P4 is 2Z to the power 4 plus 4Z to the power 3 plus 0Z to the power 2 minus 2Z minus 4. This zero term here, I'm just writing it for organizing ourselves and knowing exactly where we are and where we are doing our division. Is that right? Maybe some people might not need it, but I think I need it when I explain these things. So now what's going to happen here? Now we take this leading term. We are going to focus on this leading term. We take this leading term, we divide the leading term this side by that leading term in this binomial. What are we going to get? You are dividing only this term, so that you make the denominator 0. You make the denominator Z. So we are going to reduce that power by 1. Then we're going to get the answer as 2. I don't want to write in black, in red. So 2Z cubed. Do you agree, guys? Then we multiply this leading term here, and you get 2Z power 4. We multiply that one, and you get minus 2Z3. All together. Then this goes like this. I don't know. The influence of the calculators maybe has taken you to some disadvantage to some sort. We used to do long division of numbers in hundreds or thousands, this kind of division. If you never did in your life, you never did long division using numbers, this does not quite make good sense to you. Did you do long division of numbers? Yeah. So if you did that, this will make sense to you very, very easily. So you can see here, power 3 are thousands, under thousands. Power 4, maybe tens of thousands, under tens of thousands. So now I'm subtracting here. The difference between tens of thousands is 0. When I subtract here 4 minus 2, that will give me 6z cubed. Then I bring down my power 2 term. I'll write it there. You see why I'm doing there. This is just for organization. Maybe in some cases, if you know this thing, you know how to do this, you don't need it. But myself, I'm teaching this thing. I need to write it as explicitly as possible. Now, once I've done that subtraction, I'm having this binomial here. I go back to the leading term, divide this one. Then I got the plus 6z squared. If you can see how I'm writing in the quotient there, I'm writing it in order, putting these things according to whether they are hundreds or thousands, whatever. I always call the cubes are thousands, the squares are hundreds, the z ones are tens, and there I've got units. So I'm going to put it like that, just for organization. Then, once I've done that, I go back, multiply 6z cubed minus 6z squared to something which is doing this thing for the first time without that 0 there. It will be quite confusing, but I think this way it looks a bit organized and is accessible to understand. Now here I'm saying 6 minus 6 is 0. There's nothing there. I normally put a dot. We normally put a dot there. Then now it's 0 minus 6, which will give us plus 6z squared. Then I bring down my linear term, which is minus 2z. Are we together, guys? Sorry? Okay. Then we continue. Back to the leading term in that binomial. Divide there, you get 6z. Then you come here plus 6z. Multiplying again, 6z squared minus 6z. Am I right there? Okay. Draw that line, subtract. You get 0 there. What do you get here? It's minus 2 plus 6, which is 4z. I'm actually looking at some guys there. You are sitting down, watching this thing as if you are looking at a TV. That's not right. I wish you could be writing this thing as we're writing it, so you can feel it, and that way you get used to exactly what you must do. Just looking at it is going to make you pay a very big price, which is not good. You're not going to learn it that way. And this is my advice also. When you're looking at these video clips and listening to what is being said there, I think as the presenter is presenting, you must also try to write. And that way, I believe you make more sense of what is happening than just looking and watching. Okay. Anyway, that's free advice, no consultation fee. You take it or leave it if you don't want it. Okay. Now we come here back to the leading coefficient. Divide here, we get plus 4z. And you can see power 0, power 1, power 2, power 3, all my things are matching there. That is just for organization, nothing else. And the things are better, well organized than disorganized. Subtracting there, you get 0. Obvious, if 2 is a factor of 6, when you divide 6 by 2, you mustn't get a remainder. All together. So that's the thing there. So what do you need to do now? We can now write down here our P3 of Z is actually 2Z cubed plus 6Z squared plus 6Z plus 4. Are we together? So now I think we can now pass to the second step, number 2. That's the end of step number 1. So in number 2, what are we dealing with now? My numbering of steps, I'm not saying a number of steps, but my numbering of steps is just trying to also show you the organization of solving the exercise altogether. You move from one thing to another. You don't just jumble up your things like that. So in step number 2, we're dealing with our PZ, P3 of Z. And this is 2 Z cubed plus 6 Z squared plus 6 Z plus 4. Again, we go back to that theorem. We've got our leading coefficient there. We've got our thing. So then possible zeros equals to P, to D over L. What is actually D? D and L are factors of those coefficients I've talked about. So what are we going to have here? We're going to have plus minus 4 over plus minus 1. Then plus minus 2 over plus minus 1. Then plus minus 1 over plus minus 1. If you can check there, I've taken the factors of 4 downwards and dealing with only 1 in the denominator, only plus minus 1 as a factor of minus 2. Of 2, man. Then the next thing, what I'm going to do? I'm going to say plus minus 4 over plus minus 2. Then plus minus 2 over plus minus 2. Then plus minus 1 over plus minus 2. Am I done? Are we done? Sorry? No, we're not done. We need to get what now? Plus minus 1 over plus minus 2. Those are possible zeros. We got that one also, isn't it? And I think we're done there, isn't it? Yeah. That's the one we've got there. So we can now reduce this thing, all the redundant ones. What do we have here? No. We're not covered. We haven't covered everything here. We've left out, there it is, sorry. We've got plus minus 2 going with plus minus 1, both giving us what? Plus minus 1. Are we together? So we've got that one there as plus minus 1. Then we've got this one and that one giving us plus minus 2. What else? This one and this one giving plus minus 2. So then we're left with 4, ne? Or maybe let's take this one first. This one is repeated, eh? It's repeated, okay. So we're going to have the plus minus half. Then we've got plus minus 4. Where do you get my plus minus 4 from? From this one, isn't it? Okay. then we've got that. Then if you are faced with this exercise, you now test one by one. And the strategies, you just try to work with simplest numbers first. You can try to work with 1 first. And then maybe try 2 and so on. But it's up to you what you want to do in that case. But I'm just advising you that the strategy will be maybe to work with -1. I will try to cheat again here. I didn't say cheat, teach, but cheat. Yes? 2 numbers. What do you mean by 2 numbers? No, I don't understand now. You're saying 2 numbers, 2 factors. Which one is which? Plus and minus 1 be 0. And the plus what? The numbers I've got here is either 1 is a 0 or minus 1 is a 0, or plus 2 is a 0 or minus 2 is a 0, or doesn't mean the other one cannot be. Yeah. You understand what I'm saying? Okay. So now, because I've said here now, I'm going to cheat here because I know what is going to happen. Why I'm working this thing completely, because I want you to leave you this method complete as it is. But myself, I prepared this, I know what's going to do. So I'm not going to waste time testing individual of them, but yourselves will have to test these things individually until you get hold of one which is working altogether. So for now here, P minus 2, check P minus 2, you will see that P minus 2 is equal to 0. Can you check that? By checking, I mean push the pen against the paper and verify that you get a 0 in that evaluation. So are you getting a 0, guys? How many people got 0? Let's see. Alright, so that's 0. So what does that mean? According to the factor theorem, it means Z minus 2. That binomial is a factor of the polynomial we're talking about. In this case here, I'm writing, why am I writing this way? I'm writing exactly like the factors theorem says. The factors theorem says Z minus A. And here I'm emphasizing that my A is actually minus 2. What later happens is a simplification which I can write this way just to make that thing more or less easier to handle by combining signs there. So this is a factor of P3. So is it P3 or P4? P3. So you see my numbering 5, 4, 3. I'm just reflecting that reduction of degrees of the polynomial downwards altogether. Okay, that's why I wrote that. So now, what we need to do now, we need to find P2, because we now have a factor of P3, and we want to find the other factor of P3. We need to divide that by, we've said this thing several times, now say P2 of Z. P2 of Z now is going to be P3 of Z divided by Z plus 2. Now, I hope everybody now knows what it is. If you've forgotten this, I think you better remind yourself of these things. Z plus 2, I mean a long division of polynomials. You better remind yourself if you've forgotten. 2Z cubed plus 6Z squared plus 6Z plus 4. Do I need to highlight again my leading term here in the binomial? So we know what we do. We take our leading term, divide continuously until we get to the remainder 0. So here is going to be 2Z squared. 2Z squared plus what? 4 z squared. Is that all right? Is that all right? No. 2z cubed. Just checking whether you are actively engaged or you are just passively writing there. You can't afford to do that. So we get a 0 here. Here we get a 2z squared. Then we bring our linear term down that. We divide again. We are getting 2z. It's clear to everyone, isn't it? Then multiply again. We get 2z squared plus 4z. Then what you do, you subtract again here. You get your 0 here, you get your 2z there, you get your plus 4 down here, put it plus 4 down there. Then you divide. You get 2. Then 2z plus 4. Subtract. You can see clearly you are going to get 0 remainder there. So what are we saying? We're saying our P2 is 2z squared plus 2z plus 2. Then we can pass to the third step now. Step number 3. What are we dealing with? We're now dealing with this thing. We're dealing with this polynomial. I'm not going to write it again. I'm just going to bring it here. Now, what you can do now, you can try to do exactly what we did to find the polynomials, but this has no real roots. So once that you can fail to get the real roots, it's a quadratic equation, it's a quadratic expression, then we can appeal to finding the factors using the quadratic formula, finding find the other two roots using the quadratic formula. That's right. So now we need the formula. So Z here, we're going to get two numbers, Z1 and Z2. And if these numbers come out to be complex numbers, which we expect, there should be a number and this conjugate. Now I'm going to read the formula into this. I'm not going to rewrite the formula of A, B, Y. I'm just going to say minus B. That's minus 2. Plus or minus square root of B squared. What is 4? Minus 4AC. That is that minus 16, is it? Minus 16. All over 2A, which is what? 4. Now, underneath the square root sign there, I'm getting minus 8. And that is same as J squared 8 square root. Then which means now I'm going to have minus 2 plus or minus J square root of 8. Remember our J here represents our imaginary number. The fact that we're using J is that we're doing our mathematics with an electrical engineering bias. I think I explained that before, because I will confuse us there with our I for current. I don't know, maybe that might be true or not, but this is just done to safeguard that kind of confusion, because now you have two variables used for two different meanings. And that is in the context of electrical engineering. Please don't get me confused or upside down somewhere there. Then this is what we have got. Number and this complex conjugate. Are we together, guys? Now, so if these numbers are zeros, we can build the factors using what? The factor theorem, isn't it? So now, the factors are, now is P, 2, Z is going to be equal to Z minus, we're having things carefully here. One number is minus half plus that. So I'm going to put it there, minus half plus J square root of 8 over 2. If you want to write that square root of J over 4 in another way, it's up to you, as long as you know what to do there. Multiplied by Z minus half minus J square root of 8 over 4. And then that. Then simply this is Z plus half minus J square root of 8 over 4 brackets Z plus half plus square root of 8 over 4, that is J. Now, at this stage, guys, we have now factorized this polynomial completely. We can now say, therefore, P, I'm talking about the initial P5, P is just right, is P5 now. That P is equal to factor Z, which we call first time. What is the next factor? What is the next factor? Z minus 1. You have forgotten something which is in your book there. So you're not writing all this, you will not see it. Z minus 1. Then the next one, Z plus 2. And the last two are these ones which you got here, which you can write as Z plus half minus J square root of 8 over 4 brackets Z plus half plus J square root of 8 over 4. Then that polynomial has been factorized completely. Do you agree? Yes, guys, do you agree or not? Yes or no? So, if you go back from the beginning, there, the factor Z. In the next step here, the second factor Z minus 1. Following step, the factor Z minus 2, which is Z plus 2. Then, last step for factorization was that. Then we get our polynomial as given there. Now, if you want to give the complete set of the zeros of this, now you just have to say, now Pz equals to 0. If Pz is equal to 0, it means this product is equal to 0. All together. So, your set solution, if you do this the usual way, or your solution set, which is the right way to say it? Set solution or solution set? Solution set. Yeah, this English sometimes can be problematic how you put it around. Okay, solution set will be equals to, I think, 0. Then 1, 2, minus half plus J square root of 8 over 2 minus 2 minus J square root of 8 over, sorry, is it over 2 or over 4? So why do you let me write wrong things? Yeah? Okay. Let's clean this up, this thing a bit. Plus J, that. Okay, that's right. Or you can write this as Z equals to 0, Z equals to 1, as giving your complete set of zeros for that polynomial. Yes, what's your question? Or 2 is negative. Good. Thank you. Is that all right? So what it's telling you there, we must be careful about that. Sometimes you can write what you actually not intend to write. You just have to relook at the thing, revise what you have written is correct. So guys, this is a complete process of solving an equation with complex roots. Even if it didn't have complex roots, what we have discussed here is relevant for another equation. Not necessarily of power degree 5. You can go as further as possible, but once you get higher degrees, then the computers maybe can help you. But it doesn't make sense for a computer to help you solve find the roots of an equation when you don't even know yourself what are roots of an equation. You understand what I'm saying? This process is to try to give you the whole process, understand it. Even if the computer one day gives you junk, you can actually be able to check whether are these results correct. Otherwise, I'll say at that point, please guys, thank you for listening. As I promised, I'll put this thing on WebCity, and on YouTube. And we have got, at the end of a good day, you are going to have 2 examples. These examples and the one which I did in the other class, they're going to be both on YouTube and on my tutor. Then with those 2 examples, I think you'll be able to do any other equation of similar nature. Thank you for listening.